Assalamualaikum and hi, we're from Group 8 and the title for our studies is The Relationship of Daily Work Hours and Productivity Level. Group 8 consisted of two pairs of members, which is SABARINA binti SHAPIE and Siti binti Mohd Azli. This is the overview for our slide. The first one will be explaining the introduction. The second one is the implementation for three models, which is linear model, quadratic model, and cubic models and model of higher degree. The next one is graph. We included three graphs. Okay, the first one is graph of observed data. The second one is graph of best fit curve against its observed data. And the third one is graph of the error vector against x values. Next one is analysis and conclusion, and last one is references. Now for the introduction. In this study, we use daily work hours and also productivity level. We want to show the relationship between these two variables. Okay, so productivity is often measured by working hours, with labor productivity assessing the output relative to the labor use. So this is based from the United States Bureau of Labor Statistics. Okay, so there are impacts of working hours. Okay, while longer working hours may increase output, they can also lead to burnout and reduce productivity. So in this study, we explore the relationship between the daily working hours and also productivity using linear, quadratic, and cubic models to determine the best fit. So our objective is to analyze how daily working hours impact productivity, scores, and identify the most accurate model for this relationship.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is SABARINA binti SHAPIE. My student ID is 2021887988. So I will continue to present about the dataset that is used in this study, which is the dataset of daily work hours, which is used as X values, and the productivity level, which is Y values for this group study. This dataset is obtained from the website Kaggle. And then we move to the implementation part. So every model includes the matrix representation of the system, the normal equation, the least square solution, the best fit curve for the model, the error vector. So for linear model, the best fit linear curve is y hat equal to 52.4510 plus 3.7156x. And then the error vector that we have obtained is 38.7560 for linear model. And then we move to the implementation for the best fit quadratic curve. So the best fit quadratic curve that we obtain is y hat equals to 72.3980 minus 2.8592 x plus 0.5076x square. And then the error magnitude, which is 38.1992. Next, we are going to talk about the best fit cubic curve. And then the best fit cubic curve that we obtain is y hat equal to 260.2685 minus 99.19295 plus 16.2618x square minus 0.812296. And then the error magnitude that we obtain is 34.1652.
Now moving on to the graph part. So the first graph that I will be explaining is the graph of observed data. So the data that we use is productivity level and also the daily working hours. Okay. So the graph of daily work hours versus of productivity level is shown, okay, in this slide. So there are a lack of trend whereby there are no clear relationship because there are plots scattered around, okay, and they are far away from other point. Okay, so the conclusion that we can make is the data suggests that the numbers of hours worked does not strongly correlate with the productivity levels. Now for the second graph, okay, which is a graph of best fit curve against its observed data. In this slide, I will be explaining two models that we use, which is linear model and also quadratic model. So now for the linear model, okay, we can see that the data points are scattered around and do not align. Do not align means that they are not near the linear line. Okay, so for quadratic, okay, it also the same. Okay, the result is also the same as the linear model, but there are a few points that actually near that actually shows some alignment, but still does not align with all data points. So most probably there are other factors that um, affected the productivity levels, such as sleep hours or exercise, that influence productivity but are not included in the model. For the third model, which is the cubic model and model of higher degree, okay, the cubic model shows a non-linear relationship between daily work hours and also productivity levels. So we can observe that the data is closely aligned with the model. So this actually shows productivity increases initially with work hours, peaking around 5 to 6 hours, then decline after 10 hours due to maybe fatigue or lack of energy because due to the long hours of working. So there are extreme work hours, which is very low, which is lower than 2 hours, and also high working hours, which is above 12 hours, that result in sharp drops in productivity, which potentially reaching negative levels. So this is actually due to because, okay, for the very low working hours, because we got no time to do all the works, so we might delay some of the works later. So this can cause the productivity levels to drop, okay. However, for the very high work hours, like above 12 hours, okay, um, there are mental workload that affecting the person, okay, because if we work for too long, our productivity levels will be dropped. Okay, so the key point for this cubic model is productivity is highest within a specific range of work hours, so highlighting the impact of balancing work time.
About the graph of error vectors against the x values. So for the linear, quadratic and cubic graph, the residual pattern shows that it is randomly distributed around the zero line, and then this randomness indicates that the model captured the data trend well enough given that the residuals do not show any systematic pattern. And lastly, we can conclude that the cubic model is reasonably fit for the data. So we are going to talk about the last part of this presentation, which is analysis and conclusion. To conclude everything, cubic model is the chosen as the best fit curves because of the lowest error magnitude at 34.1652, which is the lowest compared to linear and quadratic curves. So therefore, there exists an effective range of work hours where productivity is maximized. Both overworking and underworking can lead to decreased productivity. This highlights the need for balanced working schedule for individuals. To support this, Valo and Marshall in the year of 2020 demonstrated that productivity initially increases with work hours. However, productivity decreases beyond a certain point due to factors like health, stress, and reduced capacity. Therefore, we can say that cubic model is the most appropriate for interpreting the relationship between daily work hours and the productivity scores. Final words, achieving productivity requires maintaining well-balanced working hours. Thank you.